Let's take an early look at the crash of a Cessna 172 that occurred in Colorado on Saturday, November 23rd. It was a Civil Air Patrol 172 on a training mission. There were unfortunately 2 fatalities and 1 serious injury. The aircraft was a 2009 Cessna 172T Skylane, normally aspirated IO540 that produced 230 horsepower. The pilot, we know from the FAA Airman Registry, was a commercial pilot with an instrument rating. She was a CFI with a Class 3 medical. The weather at the departure airport at 10 o'clock Saturday morning was fairly nice. 10 miles visibility, clear below 12,000 feet, and a 6-knot breeze blowing. The weather in the vicinity of the accident was dominated by VFR weather with low pressure in the area in advance of a front. This is a situation that's conducive for turbulence, and most importantly though, the weather that was advancing from the Pacific Northwest had not arrived in the region, so it was a VFR day. We do know that there was an air mitt issued for moderate turbulence, surface to 18,000 feet. Just to the west of the accident site was included in that, so it's just on the edge of it, but we know that turbulence was in the area. We also know that winds aloft in the vicinity of the accident site at 9,000 feet were 255 degrees at 34 knots, so west-southwest 34 knots. The flight originated from Fort Collins, Loveland Airport at a little after 10 o'clock Saturday morning and proceeded west. From FlightAware we know that the flight averaged between 8,000 and 9,000 feet MSL during the flight westbound to the training area, and the airspeed track showed that once they were established in the orbit, the airspeed averaged about 95 to 100 miles per hour and was characterized by flights into the headwind and into the tailwind, which are shown by plus or minus 25 or 30 knot excursions in the ground speed. The wreckage site was in a very rocky, mountainous terrain, as captured by the local news coverage. It appears that the aircraft hit some timbers and then crashed into the rocky terrain with the fuselage mostly intact. However, we do know there were 2 fatalities and 1 seriously injured co-pilot. The sectional shows the terrain that we're talking about, and we'll get into this a little bit deeper detail, but just west of Fort Collins, just to the west of the Sprague Airport, a private airport, is the accident site, just north of the river that's depicted here. And the area is dominated by the highest peak in the accident site of 8,225 feet. The next few charts will show a few perspectives of the approach to the impact point. This is from Google Earth, and it shows the ridge line and the river, and this is a very steep slope here. There's Palisade Mountain, 8,225 feet. All other terrain in the area is less than that. The aircraft flew from west to east on the south side of the ridge, crossed the ridge, and came back in and impacted along another ridge that goes north and south just from Palisade Mountain. This perspective looks to the east. There's the river, there's the ridge line, there's Palisade Mountain. There's another ridge teeing off of the main ridge that goes north and south. The impact point was just on the east side of this ridge coming off of Palisade Mountain. And finally, looking to the south, this shows the small ridge line coming off of Palisade Mountain. There's the east-west ridge line along the river, and the impact point just on this side, the west side of the ridge coming off of Palisade Mountain. The winds, as we previously said, were 255 at 34 knots, and here is the crash site on the east side of this ridge. There's the ridge that goes very steeply down to the river, and the winds are coming from about this direction, which would have caused the wind to go up and over the steep ridge, and certainly some mechanical effect here on this ridge. The next several charts I'm going to go through quickly, but it'll show the last 2 minutes of the flight, specifically with respect to altitude and climb or descent rate. The aircraft is denoted in this small symbol here. In this shot, the aircraft is 750 feet above terrain. In this shot, the aircraft just crossed the ridge heading east and is 700 feet above terrain. Here, the aircraft is 1,125 feet above terrain, again, between the east-west ridge and the river. Approaching the ridge line again, the aircraft is 1,700 feet above terrain as the pilot approaches the ridge to cross. Approaching the ridge is 1,225 feet above terrain, crossing the ridge 1,125 above terrain, then 1,375 above terrain. As you can see, the aircraft has crossed the ridge and is now flying over what looks like a little bit of a canyon sloping away from the ridge line. On the other side of that canyon, now it's 1,225 feet above terrain. The pilot turns and notice that the ground speed is now decreased to 30 knots. Backing that up, the aircraft was at 80 knots ground speed, 1,300 feet above terrain, then 67 knots ground speed, 1,200 feet above terrain, and as the aircraft turns west into the headwind, the ground speed decreases to 30 knots. Significant decrease in ground speed. We do not believe that was a decrease in airspeed. As the aircraft continues to turn around, now 1,075 feet above terrain and 43 knots over the ground, the aircraft continues now 1,075 feet above terrain, 36 knots, 900 feet above terrain, 40 knots. Now the aircraft is back over the ridge line heading west, 925 feet above terrain, 48 knots. Here we are 625 feet above terrain, 48 knots. Notice the aircraft is now at a 500 foot per minute rate of climb, and we got this data from NTSB Exchange. Crossing the ridge line now, and again, the winds are coming from the west-southwest about this direction. Crossing the ridgeline, the aircraft is now 525 feet above terrain at 45 knots, and NTSB Exchange shows that we have a 500 foot per minute rate of descent at this point. From this point until the impact, the aircraft never climbs and only increases its rate of descent. The next data point shows 650 above terrain. Notice the aircraft is over the ridgeline flying into sloping terrain, so the elevation is 650 above terrain, but a 2,000 foot per minute rate of descent. Then 475 feet above terrain, 2,000 feet per minute rate of descent. Here we're 275 feet above terrain at almost 2,000 feet per minute rate of descent. 175 feet above terrain, NTSB Exchange shows that the aircraft now is at 3,072 feet per minute rate of descent, and the impact point was at 7,925 feet in a 3,200 foot per minute rate of descent. The NTSB will examine many factors to try to understand the flight path that led to that level of descent into the impact point. Remember, the winds were coming from the west-southwest along this ridge line, over this ridge line, and may have produced some mechanical turbulence or serious downdrafts. The aircraft performance that we calculated in the pilot's operating handbook was capable of a 680 foot per minute rated climb out of Fort Collins, which was at 5,020 feet elevation, and it's capable of 500 feet per minute rated climb at 9,000 feet, which was about the altitude that this aircraft was flying at. So the aircraft was certainly capable of a climb rate in the accident area. We do believe that the abrupt changes in the observed flight profile indicates the presence of updrafts and downdrafts. The NTSB will consider many factors in this mishap, one of which may be mechanical. They'll examine the continuity of the flight control cables. They'll examine the function of the aircraft and the magnetos to determine if the aircraft engine was producing power at the time of the mishap. They'll examine if fatigue was a factor after flying for about an hour in what was probably a very bumpy flight. And they'll certainly examine the presence of updrafts and downdrafts, or the phenomenon of mountain wave caused by the 35-knot winds in the area of the crash site. It's important to point out that the number 4 cause of aircraft accidents is controlled flight into terrain, which we believe the NTSB will characterize this aircraft mishap as. So what can we learn from this tragic accident? First is understand some really pertinent mountain flying tips. High density altitude, mountain turbulence, and the presence of mountain wave are all important things to study up on. If you haven't experienced it, be prepared for it when you're in the vicinity of mountainous terrain with high winds. The FAA recommends to cross mountain ridge lines or mountain passes at 1,000 feet AGL, and if the wind exceeds 20 knots, to cross those areas at 2,000 feet AGL. They also caution against mountain flying anytime the winds aloft exceed 25 knots, and they also recommend crossing ridge lines at a 45-degree angle to allow the pilot a 90-degree turn towards descending terrain for the quick exit. So where can a pilot find resources to brush up on mountain flying knowledge and tips? First and foremost, I would recommend any pilot wishing to fly in mountainous terrain find a flight instructor that's qualified in mountain instructing. That's the first and foremost. There are many online resources available, online books, videos. A simple search of mountain flying will yield many, many results that you can pick the ones you like. And I would also invite you to check out AOPA's Backcountry Resource Center. On that website, we have ample resources for backcountry flying, but embedded within that is excellent information on flying in and around mountainous terrain. Thank you very much.